In section 2.1, we talked about this idea of applying inductive reasoning where we looked at patterns. Today we're going to look at applying deductive reasoning, okay? And what exactly deductive reasoning is very simply using facts, definitions, accepted properties, and the laws of logic to form a logical argument, okay? So this is kind of where we're going to start talking about some proofs, okay? So using deductive reasoning is when you're using facts, okay? Things that we are known to be true. And then again, recall here that inductive reasoning uses specific examples and patterns to form a conjecture, as opposed to facts and definitions. Okay, so a couple laws of logic we're going to look at. The first one is called the law of detachment. Okay, the law of detachment says that if the hypothesis of a true conditional statement is true, then the conclusion is also true. For example, if you get a hit, then your baseball team will win. You hit a home run. What can you conclude? Your team will win. Okay? So again, you have a true statement. If the first part is true, the second part has to be true. Okay? Has to be true. So if we know that two angles have the same measure, then they are congruent, and we know that the measure of A is equal to the measure of B, then that means that we can conclude that the angle A is congruent to angle B. This is the law of detachment. If the hypothesis is true, the conclusion must also be true. Jesse goes to the gym every weekday. Today is Monday. What do you know? Jesse's going to the gym. All right, so again, just using logic. It makes sense. The statement says this. If this is true, then the other thing has to follow, okay? If the measure of angle A is between 90 and 180, then A is obtuse. The measure of angle A is 125. What do you know? Angle A is obtuse. Again, this isn't groundbreaking things. This is just thinking logically. If I know this is true and this follows, then this is the conclusion that I can draw. The second one's a little bit tougher. It says, it's called the law of syllogism. What it says is, if hypothesis P, then conclusion Q, and if hypothesis Q, then conclusion R, then the thing that you can conclude is true is this guy, okay? It's kind of, you'll notice that this conclusion part and this hypothesis part kind of match up. Okay, so what that looks like is this. If Cedric plays in a big game, then he gets nervous. If Cedric gets nervous, then he performs well. So the conclusion that you can draw is that if Cedric plays in a big game, then he performs well. I apologize for my sloppy handwriting here. It's just, I don't have the best penmanship. I've already explained that. But so anyway, the kind of the way to see this is that this then part and this if part are the same. So these things essentially you can think of as kind of canceling each other out, for lack of a better way of explaining it. And what you're left with is your conclusion. So if Cedric plays in a big game, then he performs well. All right, so we're going to use the law of syllogism here if we can. So it says, if Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of water or drink a glass of milk. Then the conclusion of the statement that we can conclude is this. And this is just me saving some time here in the video. If Ron eats lunch today, then he will drink a glass of milk. Part B says, if x squared is greater than 36, then x squared is greater than 30. If x is greater than 6, then x squared is greater than 36. Okay, now you'll notice the way it's written, you'd say, oh, well, you can't do anything. However, if I think of this guy as coming first, well, then this conclusion and this hypothesis match up. Therefore, the conclusion I can draw is, if x is greater than 6, then x squared is greater than 30. All right, so again, just because it's written one way does not mean you can't flip-flop the statements, okay, to see kind of if you can cancel some things. Oh, I guess I skipped one example there on the back side. Okay, part C says, if a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all angles in the interior of the triangle are congruent. Okay, so when you look at this, if you quote-unquote cancel the common thing, Okay, you'll notice they're both the if parts. So initially, you should know right away, boom, that doesn't make sense. But then if you look at what's less, it says, then all of its sides are congruent, then all angles in the interior of the triangle are congruent. Clearly, it does not make any sense. And so there is no conclusion that you can draw here. All right. State the law of logic that is illustrated. Okay, if you do your homework, then you can watch TV. If you watch TV, then you can watch your favorite show. If you do your homework, then you can watch your favorite show. Okay, so in other words, what they've done is they've taken the fact that you can watch TV if you watch TV, and so what you can conclude is that if you do your homework, right, then you can watch your favorite show. That is the law of syllogism. All right, and these are just laws of logic, okay, things that make sense. All right. What conclusions can you make about the sum of an odd integer and the sum of an even? I want to change this to even integer. I changed it in your notes. I didn't change it on here. Okay. So if you add up an odd and an even, okay, what do you know about it? Okay, and you look at that and you start going through and you say, all right, let's see here. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 4 is 7. 4 plus 5 is 9. 5 plus 6 is 11. Right? Whatever. 1 plus 22 is 23. Okay? And so the conclusion you can make is that the sum will always be odd. Okay, the sum of an odd and an even will always be odd. Okay, what conclusions can you make about the sum of a negative integer and itself? Any negative number plus itself will always be negative. Okay, should make sense. You add two negatives, you're always going to get a negative. Never going to change. Okay, so recall here that inductive reasoning uses patterns to form a conjecture, while deductive reasoning uses facts. Patterns versus facts. Okay, example 5 here says, tell whether the statement is the result of inductive reasoning or deductive reasoning. Explain your choice. The runner's average speed decreases as time spent running increases. Okay, so we're looking at this, and the runner's average speed decreases as the time spent increases. So decreases as time increases. Well, that's based on a pattern. Therefore, this is inductive. Excuse me. Inductive reasoning. Okay, the runner's average speed is slower when running for 40 minutes than when running for 10 minutes. So if I look at 40 minutes, here's the average speed. At 10 minutes, here's the average speed. Now, this is not a pattern. This is a fact. Okay, this is a fact. These are values that we know are true. All right, that we know are true. So it's deductive because we're comparing values. All right, I actually believe I deleted this one on your notes. So that kind of takes us to the end here of deductive reasoning. So really the goal is that now you understand the difference between inductive and deductive reasoning and really what they are and how to identify when we're using which one, inductive versus deductive. So again, a lot of these ideas are going to be new to you. They're going to be different. You're used to math being kind of black and white. Here's an equation, solve it, get it right, get it wrong. And now we're looking more at logic and improving things. So as always, have questions ready or issues, and then we will discuss those in class.